There is a planet so close to its star that its entire year is only a few hours. It is so close that the gravitational force from that star locks the planet's rotation, forcing one hemisphere into permanent daylight and the other in endless darkness. It is so close that any water oceans that it may have had would have long ago boiled away. The surface rocks melt, and the clouds would hold lava rain. 55 Cancri E is a planet that can only be described as a hellscape. Astronomers believe that this planet is rocky and a little larger than the Earth. It is in a system that is 41 light-years away. The parent star, 55 Cancri A, is a K-type star very similar to our Sun and is a member of a binary system. 55 Cancri E was discovered in 2004 when astronomers took a spectrum of its parent star and noticed a characteristic wobble in that spectrum, a telltale sign that there are planets in orbit around it. These measurements suggested that there were at least 4 other planets in this system. Follow-up observations by the Spitzer Space Telescope in 2012 showed that 55 Cancri E is indeed a strange place. The first really strange thing about this planet is that it circles its star once every 18 hours. Only 1.5 million miles apart, it is so close that it has blast furnace surface temperature above the melting point of most types of rocks, covering the surface with lava. This close proximity means that 55 Cancri E is probably tidally locked. One side is always facing the scorching star. It is far from the habitable zone of the star as well. Taking up that position is the gas giant known as 55 Cancri F, a planet just slightly smaller than Jupiter. Additionally, observations from Spitzer hinted that the hottest part of the planet may be offset from the relatively cooler part of the daytime half. These observations were a surprise. If the planet is tidally locked, then the hottest part of the planet would always face the star. This puzzling offset could mean that the planet has a very thick atmosphere dominated by oxygen or nitrogen, which can move the heat around. Another possibility is that the planet is not tidally locked. Instead, 55 Cancri E could be more like our Mercury, which rotates 3 times on its axis for every 2 orbits it makes around the Sun, what's known as a 3-2 resonance. If this is true, then the planet has a day-night cycle, which would shift the hottest part of the planet. As on Earth, it would take time for the surface to heat up, making the hottest time of the day appear later. In this scenario, the surface would heat up, melt, and even vaporize during the day, forming a very thin atmosphere. In the evening, the vapor would cool and condense to form droplets of lava that would rain back to the surface, turning solid again as night falls. To help better understand what's going on with 55 Cancri E, astronomers plan to utilize the newly commissioned Webb Space Telescope to observe the system. Observations of the 55 Cancri system will be among the first exoplanets measured by Webb. Using the near-infrared camera and the mid-infrared instrument, astronomers will capture the thermal emission spectrum of the day side of the planet. If it has an atmosphere, Webb has the sensitivity and wavelength range to detect it and determine what it's made of. Nothing like 55 Cancri E exists in our solar system, but planets like this, rocky, roughly Earth-sized, extremely hot and close to their stars, are not uncommon in our galaxy. This hellish landscape is not habitable in any way for humans, but at only 41 light-years away, it is one of our closest galactic neighbors, and could offer future human tourists traveling there a tour of a lifetime.